Alright, so in this is part 4 of the Heathkit IM-5228 vacuum tube voltmeter. And in this episode we're going to look at what I did to test all the resistors, test the capacitors, go through and clean all the tube sockets, test the tubes, clean the switch, the rotary switches, the jacks and everything. And then we're going to go through the actual calibration procedures. If you like this video, please hit like and subscribe. Click that little bell so you can get notifications. And let's get into this. Okay, so I'm just going to narrate a little bit through this fast forward. This is me testing all the resistors. They're 1% precision resistors, and a lot of them are really high values, up in the mega ohms. So I test them all, as you can see here, and I do put a thumbs down on that one, as you saw, but it actually read good. I misread it on the schematic when I went back and looked at the schematic, and it was actually good. So I'm giving them a thumbs up. So I think I realized right there what I did, and then I just kind of looked at it in my head and said, okay, that one was good. So yep. So I test all the resistors, and coming up, when I actually get into the actual calibration of this, I want you to pay particular close attention to when we do the AC calibration, because there's kind of some safety tips there that you're going to need if you ever have to do one of these. So I did all the resistors were good. I tested all the caps were good. I saw a little bit remnants of spider webs in there from, if you remember from the first video, there was all kinds of spider webs in there. So I brushed all that out, what I didn't get out the first time. And here I am pulling out that electrolytic capacitor off of the power supply. It's a 20 microfarad at 150 volts. I replaced it with a 22 microfarad. And it came out pretty easy. It wasn't soldered in really very well on one side. That side there gave me a little bit of trouble, but it ended up coming out. There you see my surging glasses in the shot there. So yep, there it goes. There it is. All right. Yeah, it's a 20 microfarad, 150 volts. So I get the new one put back in and get it all soldered back up. Get it good to go. There was a lot of solder on that terminal connection, so right now I'm wicking away a lot of that excess solder where that joint was, so I can get the new cap in there. And getting it on there. This capacitor basically goes right across the line. If you remember back from the schematics, when we went over the schematics, it goes right across the secondary winding of the transformer. So I'm getting that soldered in there. Good to go. And then I just go through it. I've got a switch that's actually sticking really bad. So you'll see here in a minute that I clean that up pretty good. But right now I'm testing the tubes. This is the 6AL5 tube. It's a dual rectifier tube. It's got 2 diodes in it basically. And so I had to change the positions on the tester to test both diodes. But both sides tested good on that. No shorts. Testing for shorts right now. See the light. All right, maybe you can't see there. You can see the light when it comes on for the filaments. Yeah, Yep, no shorts on that side. Then I had to adjust it for, I'm testing the emissions on it, and it was good. You saw it go up way up in the green. I had to change the settings on the tube tester for the other diode, testing for shorts on that. It was good. Everything was good to go on that one. So this is the 12AU7. This is the dual triode that it uses in the bridge as basically a differential amplifier. And of course got it set up. It's a 12AU7 is what this is. It's a 9-pin tube. So test it for shorts. It goes way up in the green. Switch it over, test the other triode. Test it for shorts. The only thing that lit up was the filaments. It's up in the green. Good to go. So I'm going to go ahead and reuse those tubes that came with it because they're working. And I go ahead and spray some deoxit down in the tube sockets and work the tube into the tube sockets and get those cleaned out real good. And then once I get the tubes back in there, I start working on the wafer switches, and the function switch, which is the AC, DC, and ohm switch, works really well. But the range switch was actually hanging up on me, and you're gonna see here in a minute. I'm gonna actually turn the sound on where you hear it. And don't mind the radio in the background because I had the radio on, but I think it's in a commercial, so shouldn't be no copyright strike or anything on a commercial, but you never know. But it was not clicking. It was just really sticky. You can see I'm trying to figure out why it's so hard to turn, and eventually you can see it's trying to turn the whole stack. It's so hard to turn, and eventually some of that deoxit gets in there and breaks it loose. You'll see here in a minute when the sound comes up on the video. So I just sprayed one side of that shaft that goes through the wafers, and here in a minute you'll see me spray the other side and the sound to come on, and you can hear it actually kick out, start clicking in the way it should. Or take a free scan at reputationdefender.com. Let's start with all the people smitten by a certain sweetheart. Now narrow it to all those lovebirds who kind of let Valentine's Day sneak up on them and need to woo this sweetheart in a hurry. So see, now she's working like a champ. So see, that wasn't clicking before. It was really hard to turn, and now it's clicking really well. So got that all cleaned up. I went ahead and sprayed out the potentiometers for the calibration pots. And got all those going. Of course, I probably went away from, if this thing was calibrated at all at one time, probably got it way out of calibration now. So we'll see when we go to calibrate it. Go ahead and sprayed out the jack and got it all cleaned up. And right here I was trying to set the mechanical zero on there. You'll see later that I end up finding a problem with that mechanism there. So all right, so we have the test and calibration procedures here. This is right out of the Heathkit manual, and as soon as you get through assembling the unit and soldering all the components on and everything, building it basically, it takes you through the test and calibration procedures. And I've just got 2 screws in this chassis right now, so just in case I have to get back there. But luckily on this unit, all of your calibration knobs are right here on the front. So on units that preceded this one, they were inside the unit where you had to actually have the unit outside the case in order to do them. On some brands, like I think the ICO has them over here on the side, but these are all straightforward right here where you can see them. and it's going to be really easy for us to stick our little calibration tool in there and turn it. So we're going to run through the procedures here. The only one we're not going to do is the ohms check, because that requires a battery. And in the next part of this, the final part of this VTVM, we're going to go over how to install a battery eliminator in this circuit with the LM317 voltage regulator, and we'll get rid of that battery, and then we'll do the ohms check at that time. So I'm not going to bother doing it now. We're going to do the zero adjust, we're going to do the DC calibrate, we're going to do the AC calibrate without the line cord adapter, meaning that I've got this thing plugged into a 3-prong grounded receptacle. So that's the directions we're going to follow here. This is going to be very important to pay attention to this procedure right here when we do that, and we'll get to that when we get to it. The first thing we have to do is with the VTVM, the meter off. Okay, we got to turn this plastic screw right here to where we get a 0. So that is going to basically give us our mechanical 0. I'll try to get this squared on here so you guys can see it. Again, this thing doesn't have a mirror. I'm going to be looking at it squared on, so I don't know how it's going to look in the camera, but hopefully it looks correct here. Let's see. Yeah, this thing's touchy. Okay, so right there should be mechanically 0 right there. Okay, and then the next function check that we're going to do is the zero adjust function, and that's with the unit set to the DC plus, but without any without our probes connected. We're not going to have our probes connected for this test. Okay, so we don't have the probes on. It says check operation of the zero adjust control. Turning this control should move the meter pointer part way up to scale. So, and you really want your tubes warmed up a little bit before you do this. So I'm going to go ahead and let them warm up. You can see the light comes on here. I don't have a lot of light in the room, so you probably don't see it, but the lamp, indicator lamp, power indicator lamp's on. Okay. So we'll let this thing warm up just a little bit and we'll come back. Okay, so this thing's warmed up a little bit, and what we're going to do here is, let me get this back over here. We got it on AC. We're going to move this to DC plus, and you can see our needle has moved off 0 where we had it when I turned it on. So if I turn it off, it should go back to the mechanical 0. Okay, so I found a problem with this when I was I noticed that the meter was jumping around a lot, and if you see right here, okay, so now that I got this thing off and I'm looking at this, when I pulled this off, this little tab was supposed to be sitting inside this little hole right here, this little slot right here on the meter movement. And you can see if I put something in that and turn it, it will move that needle. See? And this is how you're going to mechanically 0 this thing. You can see I can move the needle back and forth. Well, when I pulled this thing off, this little tab was not inside that slot. It was on the outside of it. And you can see, because of this crack, this thing is kind of it's not even in there straight. So I don't know if it being out and people torquing on it is what made this crack, or whatever made this crack made this thing come out of the slot, but that's what the problem was with that. So I've got another cover, and I'm going to try it, or maybe I can just put a new, well, I don't know if it's the crack that's causing it. Then yeah, you can see somebody tried to glue this, so, and it's just in there kind of cockeyed. But yeah, I'm probably gonna have to put that other cover on there. That's fine. I didn't really care too much for this crack anyway. So anyway, we're going to calibrate it without the cover on it. How's that? So let's go ahead and set this to mechanical 0. Since I messed with it, I already had it set, but there we go. All right. So that was with the AC off. And actually, we shouldn't have even had the plug in there, really, for that part. But let's try it again. Okay, it stayed. Okay. All right, so let's start with the... We'll get there. All right, so the DC calibrate. Or the 0 adjust, excuse me. We need to be on the DC plus. And we need to set it for the 0 position. It says that when you turn the control, it should move the meter pointer part way up the scale, which it does. Okay. And then set the pointer to the left side of the scale at 0. So that's what we're going to do. Right. There. Okay. It may be a little off in the camera, but for me, it's right on the money. Okay. And then what's going to happen is I'm going to flip it over to DC minus, and I shouldn't get any deflection whatsoever. I got a little bit. It says that you should not get more than 2. You should not get more than 2 divisions on the scale movement. So let's see. That's too much. Get this down. Right there, rock steady. Okay. Good. Okay, so that's our 0 adjust. That's where we need to have it. And then the next step is the DC calibrate. Okay, so we're going to insert the test lead phone plug, and we're going to do the DC calibrate. All right, so I'm going to put, here's my DC probe. And here's my return. All right. Now, what does it say here? Set the function switch to DC plus, which that's what we have it on. And range of 1.5, that's what we got. Connect the probe and common test leads to the flashlight battery cell. Okay, so, you know, this instructions basically was like, okay, you didn't have anything except for the battery that came with this unit, or the battery you were going to put in this unit. So it had you test the battery, but what we're going to do is we're just going to actually put it on a DC source here. So I think that's the best way to do it. So what we're going to do is I'm going to just flip on my DC source. Got my DC power here. I'm going to slap this up to 1.5. And I'm probably going to stick my meter on it too so we can see. But okay. All right, so I got this dialed into pretty close to 1.5 volts, so that should be good enough. All right, so let's see where we're at here on this, and we're way off. And when I cleaned these earlier, I turned these a lot, so they're probably way off. So we're going to get this right up to 1.5 and leave her right there. Okay. So that's the DC positive. All right. So now we're going to move on to the next step, which is AC. I'm going to skip over the ohms check. So this is very important on this because, and I will show you right now what I'm talking about. Let me rig this up a minute. Okay, so what I wanted to show you is this. Right now I have one of my test probes tied to the ground terminal, Right now I have one of the test probes tied to the ground terminal and the other one tied to the alligator clip, which is the return for your voltmeter probe. And you can see I got continuity here. So internally inside the case here, the return is tied directly to the case, and so is this power ground on the power plug. So what you don't want to do when you're working with, if I want to test the line voltage with this meter, I do not want to use this alligator clip at all, because, well, I mean, if I go to the right terminal, it could be all right, but I don't need it at all. Basically, all I need to do is take this AC probe, and on one of them I'm going to get close to 0 volts. On the other one I'm going to get whatever I'm trying to measure, the 120 volts or whatever. And that's all I need, because this pin right here is actually making the return on here. So it's tied to the neutral back at the panel. So the last thing I want to do is put this on the line side and short it straight to ground, which is what essentially I would be doing. So you can do this one of two ways. You can follow the directions like it says here, which that's the way I suggest it, or you can plug this into an isolation transformer with an isolated ground and just probe with both of these, and that's fine. There you go. Bob's your uncle. Here we go. So let's, we're not going to use this ground clip right here. I'm going to go ahead and plug this back in. We'll get the meter back up and running, and we'll do the AC calibration test. And I'm going to be using my meter here too to, well, actually I've got a meter on the Variac itself, so I'll just use that and calibrate it to that. So let's get this thing going. So we need to do our balance first. So you can see how this is jumping when I go. See that jumping? Okay, so I need to get that where that doesn't happen. And it's on 0. Okay. Okay, and now it shouldn't jump. Whoa, I didn't even have that in the frame where you guys could see it. Sorry about that. So I got this on 0, and this shouldn't jump at all from AC, DC minus to DC plus. More than 2 segments. It's not really jumping at all. It's not even jumping a whole segment. So we're good there on the AC balance. Now for the calibration, we flip over to 150 volts. And we plug in our jack here, our plug into our jack. And then I'm going to stick this meter. I've got my Variac set at 120 volts. So let's see what it looks like. And right now, since we're on the 150 volt scale, that's this top scale right here, the top black scale. And basically, whatever you're reading here, you multiply by 10. So that's about 559 is what this is reading. So it's way out of cal. So let's see what we can do with that. Maybe we can get it up there. We need to be up to 120 volts RMS. Now, this meter is a peak voltage meter, but it's calibrated, the scale is calibrated in RMS. So you're actually reading RMS voltages on here, which is what my Variac voltmeter up here is reading, is RMS, 120 volts. So that's what we should be at. So we're at 120 volts. Obviously to you guys, it probably looks a little off, especially with this lighting. It looks like it's got some parallax, but I'm sitting here right on it, and it looks to be right about 120 volts. So right there. All right, I'm going to vary the voltage on my Variac a little bit. Again, this is the same voltage that the thing is plugged into, but we'll see if it actually moves here. Yep, I just varied it slightly. All right. But that's basically all you do. So you start off with the mechanical 0. And like I said, I'm going to have to replace that I'm either going to have to replace this mechanism right here or replace the whole cover, which I have another cover. It's probably a little better shape than this one. This one's got a crack running through it where that one doesn't, but this one's kind of chipped on the other one is kind of chipped on the side over here. But I think the mechanism here is good on it, so I may replace that. So you're going to do your mechanical zero first without it being powered on, without a jack in it. Then you're going to do the zero adjust, and that's with the power on, and after it's warmed up for a while, and no jack in. And then you're going to do the DC plus calibration, and that's with the jack in and a known DC source using your DC probe. In this case, the black probe, or in this case, the red probe. And then you're going to do the ohms adjust, and that's going to be this knob right here. Remember, we didn't do that because we're going to do that in the next video when we do the battery eliminator circuit. And then you're going to do the AC calibration. And remember, you're not going to have a line cord adapter. In other words, what the line cord adapter is for in this instruction is it goes from a 3-prong to a 2-prong. So if you got old receptacle or something like that, you don't have a ground, you'd have to use that line cord adapter. And there's different instructions for how to do that. And remember, when we did this without the adapter on the 3-prong system, we did not use the alligator clip. I just got my voltmeter right there in the socket of the Variac, as you can see. And I'm reading 120 volts on my VTVM right there. So, well, and I'm out now. So I will tell you this. It does tell you to have these tubes warm up for about 20 or 30 minutes before you calibrate this. And maybe I didn't wait that long, so it's probably drifting a little bit. But those are the basic steps. And okay, that'll do it for part 4. Hope you enjoyed this episode. In part 5, we will actually put in a battery eliminator circuit with the LM317 IC voltage regulator, and we'll source our 1.5 volts off of that, and we'll also do the ohms range or the ohms function resistance calibration on the meter. So until the next video, be safe.